Welcome to Chapter 3. We're going to take a look first at the PowerPoint slides located in your multimedia library. We will then take a look at a couple of the homework problems and how to use StatCrunch. Please keep in mind that there is an additional StatCrunch YouTube video loaded that focuses specifically on Chapter 3 and the software. In the first section in Chapter 3, we take a look at measures of center of a data set. These should be familiar to you because they would include things such as mean, median, and mode. The fourth one, the mid-range, may be a little bit less familiar, but you should quickly see how to compute it. The arithmetic mean is found by adding up all of your values and dividing by the total number of data, or what we call the average. The notation, however, might be new to you. First, you have summa, which means sum. X is the variable used to represent the individual data. Lowercase n is used anytime we're talking about a sample, and uppercase n is used anytime we're talking about the number of data in the population. So the mean is computed for a sample by writing x bar is equal to the sum of x divided by lowercase n. If we are, however, referring to the results of a census, values about the population, then we would have mu equal to sum of x divided by capital N. We do use two different symbols so that we can clearly tell if we are dealing with a sample or a population. Of course, the mean is quick and easy to compute. However, it is very sensitive to extremes. Think about what happens if a lot of people have 60s and 70s on a test and somebody has a 95. It makes the average look higher than it really probably is for the class. So if you're stressed while you're studying your statistics and you decide to eat some chocolate chip cookies, stop and think about how many chips are in the cookies. Here we had 5 cookies and we've counted the number of chips in each. We want to find the average or the mean. So we add the 5 numbers and we divide by 5. There's an average of 23.4 per cookie. The median is the next measure. This is the middle value after you put your data in order. It's often denoted by what we call x tilde, but a lot of times we might also just write the word median. To find the median, we first put our data in order, and then we look for the middle score. If, however, you have 2 middle scores, you will average the 2 in the center. The mode is the score that occurs the most often. You might have a data set that has 1 mode, 2 modes, 3 modes, or perhaps no mode. If there is no mode, you simply write the words no mode. Do not use 0. Take a look at these examples. In Part A, the mode is 1.1. It's repeated. In Part B, the 27 occurs 3 times and the 55 occurs 3 times. In Part C, there's no mode. There's no repetition. The mid-range, or the fourth measure of center, is the value halfway between the highest and lowest values in your data set. Simply find the least and the maximum value, the minimum and maximum value, add them up, and divide by 2. It is sensitive to extremes, and because of that, it's not used very often. However, it is quick and easy to do, and it is one of the other ways that you can determine the center of your data set. Think about whether the results you get are reasonable. Think about how the data was collected, and determine what might be the best measure of center for your data set. Take a few minutes to read through the rest of the slide notes, such as calculating a mean from a frequency distribution. If you have multiple occurring scores in particular classes, it may be faster to group them into a frequency distribution and then calculate the mean. You use the class midpoint, representative of each class. In a few minutes, I will show you how to do that on StatCrunch to save you a little bit of computational time. We can also talk about what's called, of course, the weighted mean, where you have weights assigned. This is common, for example, with GPAs. And so you can take a look here at the example for finding the weighted mean. If you had, for example, a 3-credit class and earned an A in it, you would take 3 times 4, the point value for an A. Down here, you will add up the credits for the course, and so you will take the total weight divided by the number of credits to determine that the student's GPA in this case is a 3.07. In our next section, we're going to take a look instead at variation or dispersion of scores. Range, of course, is the simplest form, the difference between the highest and lowest value, or the max and min in your data sets. However, it's very sensitive to extremes, and so we're going to use a different measure far more often. The standard deviation of its data set, denoted by S, is a measure of how much your data values deviate or differ from the mean. Here's the formula. Notice that you have the sum of the squares of values where you take each individual data and subtract the mean. We are not computing this by hand. We will be using software. However, you do want to understand that standard deviation is a formula used to find, on average, how much your data deviates from the center or the mean of your data. The standard deviation is a measure of variation. It is positive. It is never negative. You can't have negative deviation. And if you add one or two extreme scores, what we call outliers, your standard deviation can dramatically change. The units are the same as the units of the original value. So if you're measuring something in number of hiccups, then the standard deviation is number of hiccups. If you measure something in grams, then your standard deviation is in grams. Here again is an example where we take the values. This is being done manually. The standard deviation is 1.91. We will be using StatCrunch to compute. The range rule of thumb is based on the principle that for most data sets, when we're dealing with normal distributions, the vast majority, meaning 95% of our data or more, are going to lie between two standard deviations from the mean. If you take the mean and you add the standard deviation twice and you subtract it twice, you will find a range in which most of your data, if not all of your data, will fit. So the data that fits in that range is considered to be usual values, and the scores that fall beyond those points are considered to be unusual. To roughly estimate the standard deviation from a collection of data, you could simply take the range and divide it by 4. That would be a little bit larger than the real value for your standard deviation, but it's a good ballpark figure if you're dealing with a large data set and did not have time to do the computations. If the mean was 24 chocolate chips and the standard deviation was 2.6, would a cookie with 30 be considered unusual? Well, let's find out. 2.6 times 2 is 5.2, so we're going to add 5.2 to 24 and subtract 5.2 from 24. That gives us a range of 18.8 to 29.2. That would be our usual range. Anything falling outside of that is considered unusual. So 30, of course, would be above the maximum usual value. That would be a cookie where you got some bonus chocolate chips. That's an unusually high amount of chocolate chips. It's a good practice to compare the standard deviations of two sets only when sample means are roughly the same. So keep that in mind if you were comparing two different brands of chocolate chip cookies, for example, or we're comparing two different sets as you do in your homework problem about beauty contests. If we're comparing variation samples that are very different, a better measure to use would be what's called coefficient of variation, and we'll learn about that in a little bit. In our notes, we then look at variance. The variance is basically the square of the standard deviation. We again have different symbols. S squared stands for sample standard deviation squared. Sigma talks about the population value. So keep in mind, again, we have different notation just like X bar and mu. So again, review your notation. These are important to keep in mind. Now, a very key idea in this chapter is the empirical rule, or what sometimes is called the 68-95-99-7 rule. If you have a roughly normal distribution, what we call a bell-shaped curve, and you have the mean, and you add and subtract the standard deviation one time, approximately 68% of your data would fall within that one standard deviation mean. If you did that 2 times, approximately 95% of your data would fall within that range. And if you went out 3 standard deviations, you would have virtually all, or 99.7% of your data. This is a great visual to help you keep track of this rule. Notice you can also, since it's symmetric, cut these values in half. So for example, 34 and 34, 13.59, 13.59, and then the little tails at the end. Chebyshev's theorem is an alternate theorem for when we would have a set of data that is not normally distributed. If IQ scores have a mean of 100 and a standard deviation of 15, what could you conclude from Chebyshev's theorem? Well, about 75% of your scores would be within 2 standard deviations of 100, being between 70 and 130. However, if that data set was normally distributed, you would have 95% of your IQ scores between 70 and 130. We alluded to this earlier, the coefficient of variation. And the coefficient of variation is found by taking the standard deviation divided by your sample mean or your population mean and multiplying by 100%. It basically describes the standard deviation relative to the mean. In our third section in Chapter 3, we take a look at measures of standing. We take a look at such things as percentiles, z-scores, and box plots. The first one here, the z-score, is the number of standard deviations that a given value is above or below the mean. If the z-score is positive, the data is above the mean. If the z-score is negative, the data is below the mean. If your z-score is 0, the data is equal to the mean. To compute it, you take your individual score, subtract the mean, and then divide that difference by the standard deviation. Again, notice we have two forms of this formula. One, if we're dealing with sample values, and the other, of course, if we're dealing with population values. In this particular population formula, you will see mu and sigma instead of x bar and s. Keep in mind that, quote, usual or ordinary values for z will fall between -2 and +2 standard deviations. Z-scores beyond 2 or below -2 are considered to be unusual. So the author of the textbook measured his pulse rate to be 48 beats per minute. He was nice and relaxed while making problems to stress you out. Subtract the mean, 67.3, and then divide by 10.3, and you get a z-score of -1.87. Because his z-score is between -2 and +2, his pulse rate is not unusual. You've probably heard about percentiles before. They are measures of location. They are used when you have a larger data set and you want to divide your data into 100 equal parts, with about 1% of each of your data in each group. The fastest way to find the percentile of a data value is to take the number of data less than the x value that you are working with and divide by the total and multiply by 100. So for example, if we look at our chocolate chip cookie data again, and we wanted to find the percentile for a cookie that had 23 chips, we would see that when we go to 23, there are 10 cookies with fewer than 23 chips. So 10 divided by 40 multiplied by 100 gives us 25%. A cookie with 23 chips is marking the 25th percentile, or about a quarter of the way through the data set. If, however, we're given the percentile and we want to find a data value that matches it, we're going to use what's called a locator here. And we would take the percentile divided by 100 and multiply it by the size of our sample. If L, the locator, is a whole number, you would count to that position in the data set and average that number and the next number to find the value of your percentile. If L is not a whole number, you will round it up and then use that position in the data set. You could have also talked about quartiles, quartile 1, 2, and 3. Quartile 1 marks off the bottom 25%. Quartile 2 is your median, which is exactly halfway through your data set. And quartile 3 separates the bottom 75 from the top 75%. If you first find the median, splitting your data into two equal sets, then split the bottom half in half, that will help you find Q1, and then split the top half and you will find Q3. When we use StatCrunch, StatCrunch will print out the values of the Q1, Q2, and Q3, as well as mean and standard deviation and other key information we're learning in this chapter. This is a visual where you can see how the data are sorted into 4 equal parts. Some other basic statistics that may be computed using the quartiles, what's called an interquartile range or a semi-interquartile range or a mid-quartile or the 1090 percentile range. These are not computed as frequently, but they are certainly used depending upon the study being done. We will use what is called a 5-number summary. A 5-number summary contains the 5 key data values for your data set, the minimum value, the maximum value, and the Q1, Q2, Q3. That helps you take a quick look at the visual presentation of your data using what is called a box plot. Here's a typical box plot showing us the least, the minimum score, the highest score, the maximum, and Q1, Q2, Q3. Right away, when you look at this data set, you can determine that it is not normal. This box is not centered in the middle of our data set. nor is the box equally set so that you could fold it in half and the two parts were symmetric. We can tell that this is a right skewed distribution because the tail on the right is just slightly longer. Here's a normal distribution for heights of women. The heights range from 59.1 to 67.8 inches in this particular sample. Notice that the center, the box, contains the middle 50%. So 50% of our women were between 5'1.5" inches and 5'5" inches. This is obviously an even more dramatically skewed distribution for salaries in thousands of dollars of NCAA football coaches. We've already alluded to the term outlier, and you will notice that on some of these box plots you will see a small asterisk or star, and what that indicates is a value that's so extreme from the rest of the data set that we call it an outlier. The software can easily compute this for us and mark that off on our box plot. Why are we concerned about outliers? Because they can have a dramatic effect on your mean as well as your standard deviation. And so it can also affect your histogram. So when you're trying to see, am I dealing with a normal distribution or not, you may be unable to tell because the outlier can have a fairly dramatic effect on that. Because of that, when we are constructing a box plot, we will always choose the option to show outliers if applicable. This creates what is called a modified box plot so that we can see where those values might occur. Here's an example. This was pulse rates of women, and you can tell that there are two women who are pretty atypical with respect to the rest of the group. Most everybody else scored between, let's say, 60 and 95, but here we have somebody who has 105 and someone whose heart rate was 125. If we trim those out, then you can see that our set looks a lot more normal and predictable. Keep in mind these tools you've been looking at in Chapter 3 still tie in with Chapter 1 and 2. We need to be considering the context of the data. Where was the data from? How did we sample it? What does it look like in pictorial form? Are there changes in patterns over time? And what conclusions are we going to draw from our data? Always remember, we need to be thinking critically about the results that we get. Now, let's take a look at a few of the homework questions. Remember that when you see the small box on the homework problem, you can click to open this in StatCrunch. This first question here asks us to find the mean and median of two sets and compare. So we're going to open this in StatCrunch, and we're going to do summary statistics of the columns. Anytime you want to select more than one column or row, simply hold down your Control key and click both of them. We're just going to go ahead and click Select Compute. And so it's very easy to look here and see the mean of both data sets, 3.3, 2.8, and the median for both data sets is 3. You can even edit your output to only compare the two things that you want to have. If you only want the mean, again, hold down your Control key, click Median, and this time your output will only contain the two summary statistics that you're looking for. On another question, we're asked to find the standard deviation, range, and variance. So again, we're going to click to open in StatCrunch. We're going to choose Summary Statistics. And since we only want the standard deviation, mean, and variance, we're going to click those values. Range, standard deviation, and variance. Notice our output simply lists the three measures of descriptive statistics that we are looking for. Another question asks us to find range, variance, and standard deviation. We do that the same way we did the last problem. This next one asks us to find coefficient of variation. In order to compare the BMIs from the two sets of beauty winners, you're going to go to StatCrunch, run your summary statistics for both columns. But remember, in order to do coefficient of variation, you only need the mean and the standard deviation, so we can just select those two values. To compute the CV, then, you take your standard deviation and divide it by the mean. And pay attention to the rounding rules. Here it asks us to round our answer to 2 decimal places. There's a problem then where we're going to be taking a look at doing z-scores, doing percentiles, and then we can watch and work through some different types of questions regarding the video lectures that we watch. Now we're going to take a look at one more problem, and that is finding the frequency distribution, or taking a frequency distribution, finding the mean. This is often one that's rather cumbersome to do on paper, but it turns out that this is pretty nice to do in StatCrunch. So we're going to copy our chart over to StatCrunch, and remember, we want to find the mean of the frequency distribution. If we were doing this by hand, we would use the midpoint of each class, so 42, 47, 52, 57, 62, as representative of the data in the class, multiplied by the frequency, and continue to do the problem. You can, however, simply go in here, click Summary Statistics, and use grouped or binned data. The bins, or the groups, classes if you will, are located under temperature, and our counts, or frequencies, are in the frequency columns. The midpoints are defined by an average of our limits, so we don't need to change anything. And we just simply want to find the mean. So we're going to click mean, and we're going to see that our mean here is 51.615, and it says to round to the nearest 10. So we could come here and go 51.6, and we would check our answer, and we found we had the right answer. Then we would continue to answer a conceptual question about the value and what does it mean to us. Just a reminder, if you were actually asked as well to compute anything like the standard deviation for that data set, all you would need to do would be to go back and select mean and standard deviation, and it will tell you both the mean of that data set as well as the standard deviation. Quick and easy. So again, summary stats like we've been doing before, but this time since we're using grouped data, we're going to choose the last option, grouped data. Okay, watch the other video about using StatCrunch for Chapter 3, and you should be good to go. Good luck!